You go into your Blackboard for 1483, and it is the top module. It says attendance. You click on it and you enter the code. You're welcome. Okay, so I'm going to share my screen. Make sure you guys can get into Desmos here pretty soon, Desmos graphing. If you are not able to get into Desmos because you're like on your phone or something, then there are instructions, which I actually learned something with this working through it. Um, Using Desmos is what we're doing today. I didn't know we could do it this way. So I have learned something, which I will promptly be using for my high school students like next week. Okay, so I'm going to share my screen. Okay. No, I 100% labeled that wrong. This is 1.3. This is 1.3, not 1.2. We did 1.2 last week. Okay, so now I gotta fix that because it's gonna bother me. Okay. Domain and range of functions, piecewise functions. So we're gonna find domain and range from like equations. We're gonna find domain and range from graphs. We're gonna find we're gonna learn about the different notations that you can use. There are two that we're gonna talk about. And then don't panic on that last one, graphing a piecewise function. You're gonna 100% do that in Desmos. Okay? And it's written exactly how to type it in. Right. So the set of all possible inputs. All right, this is called your domain. Okay, these are all of your x's. All right. The set of all of your outputs, that's called the range. These are all of your y's. Regardless of which one you're doing, it's always least to greatest. Okay. Sometimes that means infinities on either side, negative infinity or positive infinity, and sometimes that means an exact value. Okay. Sometimes that means you list individual points. They're called discrete points. Okay. So in this first example, identify the domain and range of that function. Okay, I can see that it's a function because there's no repeating x's. All right, 2, 3, 4, 5, and 6. Nothing repeats. So the list of the domain as best you can. And you guys know, obviously, I can't see what you're writing, but I will 100% not judge. You draw a brace, which is like a curly cube bracket. Good luck. Nobody's judging. And starting from the least, the like smallest x to the greatest x, we're going to list them. Okay, so the smallest x there was a 2. Next one was a 3, followed by a 4, then 5, and then 6, and we close with another brace. Sometimes the braces look really good and sometimes less good. Nobody's judging. You do not use parentheses though, so do the best you can with a brace. All right, then you list domain, or we list range. Um, you don't list repeating values. So if the value is repeated, you only list it one time. All right, and I say that because we have a repeating 10. Not a big deal. I just only list it the one time though. So we do another brace. Smallest y is the 10. It's there twice, but you only list it once. And then the next one there is 20 and 30 and then 40. Okay, so it's pretty straightforward when you're given individual ordered pairs. In order from least to greatest, and if it's repeated, only list it the one time. Okay, there's a lot of information coming up, okay? Um, these two charts on these pages, if you don't already have them printed out, I don't want you to spend a whole lot of time trying to draw it out. You can go back and find it in Blackboard, okay? These give literally every type of example possible for what's called inequality notation, right? The other type of example is called interval notation. So intervals, there it goes, regardless of um, what the beginning and the end is, this is always has a beginning. That's the first number. And it has an end. Okay, so even if it begins at an infinity, it still begins at an infinity. It has a beginning and an end. And again, I don't want you to spend time trying to copy this down. We got a ton of examples that's going to get all this put in there. But we start off with this inequality. It says x is greater than some number. All right. In interval notation, if I'm saying that x is greater than this a, that means a is the smallest. Everything is bigger after that, which means what did I say? Did I say everything gets bigger after that, or did I say everything gets smaller than that? How do I not remember what I just said? It's a great
You
day.
said everything gets bigger.
Okay, so everything gets bigger after this. Thank God. Whew, I was about to panic for a second. Okay, so since A is the smallest, everything gets bigger from there, which means A is the beginning of the interval. Well, it doesn't tell you an end. It just says X is greater than A. So I could have a number that's like 7,500,000. It's still greater than A. So we end with this thing called an infinity sign. All infinities have parentheses. It doesn't matter what comes next. Okay, so that's inequality, interval, and then we have a number line. Okay, you're going to see your value, the A, whatever it is. And then I never use this notation. I actually hate this notation. I'd rather use, and you'll see it here in a second, an open dot. I don't like the parentheses on a number line. It just drives me insane. And you see how I have this blue arrow that's kind of pointing off to the right? It means everything after that. This is a number line. So if I'm on the right side of A, everything is greater than A. We can go vice versa. Now I have X is less than A. Okay, which means A is the biggest. So it's the end of your interval. If it's the greatest, then it's the end. It's the right side. All right, but we have to begin somewhere. So all the numbers that are less than A, negative infinity to A. And again, I would rather use an open dot than a parentheses any day. And you see how I have an arrow pointing off to the left. Anything that's on the left side of A is considered less than. So X is less than A. Then we have these two with equals to. Okay, so that little line underneath your inequality symbol. This is what we call inclusive. It's just fancy for saying it's included in my interval. All right. So if I want a number that's greater than or equal to A, then that also includes A. So let me give you a better example. Let's say that X is greater than or equal to, I don't know, 7. Okay. Is 7 greater than or equal to 7? Yeah, it's that equal part of it. So 7 falls inside the answer, right? That's why it's called inclusive. 7 is part of your answer. Right. So the difference is that instead of a parentheses, you have a bracket. Okay. And instead of a parentheses or a bracket on your number line or an open dot, you have a closed dot. You're good. Right. Less than or equal to, again, this is inclusive because of that equals to. Right? That means that A is included in your inequality and it's part of your answer. All right. So just like the other ones, if I have a greater than or equal to, that means that A was the smallest. Everything's bigger after that A. If I have a less than or equal to, that means your A was the biggest. Left side versus right side. All right. So again, I would rather use a closed dot any day. I do not like the brackets on my number lines. Mainly because that's not how I was taught. Okay, flipping page. Give me 1 second. My dog is like crying out there. And then we have these guys. These are called compound inequalities. All right. And I like these for interval notation because you can see the beginning. I'm starting at A and I'm ending at B. And you see where that X is located? It's somewhere in the middle. All right, so this is basically read as X is greater than A, if you have any room to write it, but less than B. It means it's in between. It means, sorry. What is it? No, okay. All right, so we're beginning at A, ending at B, and you see the parentheses here, just like on the other page, open dots. All right. On our next one, you see an equals to, okay? Means X is greater than or equal to A, but still less than B. So A would get a bracket, A would get closed dot. But I know you guys can see the rest of these, so I'd rather just go into the actual examples because I hate these. But at least you have them all there. So your number lines, okay, included. You remember I talked about that word inclusive. Oh my God, my dog. Holy cow. Pros and cons to being at home. So inclusive, what that equals to, gets closed dots, or brackets. Excluded. There you go, feel the pain there. Excluded uses open dots or parentheses. If you've got them printed, I want you to highlight this too. Parentheses also go with your infinities. So these are the notations that we're going to use. So their next couple examples are actually our next several examples. Draw the line graph and use interval notation. Okay. So I'm only going to go through the way this is worded like once because this is a weird notation here and I don't use it very often. But this part right here, okay, that is fancy for saying all of the x's when x is less than 2. It's basically writing a sentence as symbols. Okay, so all the x's when x is less than 2. I have a blank number line here, all right? You're going to put a 2 somewhere on that number line. So I'm going to put it here where I can. All right. Then I'm going to look at the symbol. This is a less than. Less thans are exclusive. Okay, so I'm going to use an open dot on my 2. Excuse me. Okay, now I've got a choice. I'm either looking at the left side of my 2 or I'm looking at the right side of my 2. Okay, well, consider a number line real quick. All right, so on the right side, if I'm on a number line, this is 3, 4, and so on. On the left side, 1, 0, -1, and so on. If I want the x's that are less than 2, that is going to be on the left side. Because the 1, the 0, the -1, and so on, all of those values are less than your 2. So you draw an arrow pointing that direction. Okay, I'm drawing a really exaggerated arrow so you can see it. And then you do continue it with an arrow at the end, just so that represents that every number that's less than 2 is on that line. That means that line is still going. Questions on the number line part? Okay, now I like looking at the number line here because I can see a segment. I have a beginning and I have an end. So if I look at the beginning, I see that my beginning is an arrow. So I'm looking at my beginning. Okay, not only is my beginning an arrow, it is a left arrow. It's pointing this direction. That means your beginning is negative infinity. Now I need an end. Okay, well, I started at negative infinity. Where does my purple line end? It ends at 2. Good. Put a comma, beginning, ends, all infinity signs, get parentheses. And your 2 has an open dot. It's just a less than. It's an exclusive value. So it also gets a parentheses. Okay, with me here? Okay, let's go to the next one. Okay. All x's when x is between -3 and +5. That's what this symbol is telling me. All x's that are between -3 and +5. And it's also inclusive. How do I know it's inclusive? Equals 2. All right, again, I don't care about spacing or anything like that. So you're going to put a -3 and a +5 on your number line. Okay, so when we look at that -3, it's got an equals to. It's a closed dot. +5 also has an equals to, closed dot. And then you see X is literally in the middle. So I need to connect so that X is literally in the middle. Right, so any number that falls in between -3 and 5 is a solution to this. So I can say 0. Does 0 fall between -3 and 5? Yes. Okay, could I say -3? So put it in the chat. Could I say that -3? Yes. Perfect. How do you know? Yeah, we got that included, that equals to. I don't know what you call it. I mean, it's an equal sign. I think it's just part of it. All right, it's got an equals to. Perfect. Okay, now let's write the intervals. So you need a beginning and you need an end. I'm beginning at -3 and I'm ending at +5. So beginning, end, beginning and ending. -3 has an equals to. It's a closed dot. It's a bracket. 5, also inclusive, equals to, closed dot. It's another bracket. Okay, moving right along. All x's, where x is greater than or equal to -1. Put -1 on your number line. I don't care where you put it. In the chat, tell me if it's an open or closed dot. Good. Closed dot it is. All right, so now we consider, it says x's have to be greater than or equal to -1. Well, I got to choose the right side or I have to choose the left side. Which side of the -1? Give me x's that are greater than or equal to -1. Awesome. On the right side, good. Now we write the intervals. Beginning. I'm beginning at -1. Okay, my ending. My ending happens to be an arrow. And it's pointing to the right. So if it's pointing to the right, that means it is a positive infinity. -1 is closed. Bracket. All infinity signs. Parentheses. Okay, and our last one, we have all x's, where x is between -1/2 and +3. So you're going to put both of those numbers on your number line. I don't care about spacing. What kind of dot am I going to put on the -1/2? Got to say lots of this. Open dot. What kind of dot am I putting on the 3? Good. Lots of closed. All right, and since x has to be between, okay, that means x's have to be greater than that -1/2, but less than 3. I'm going to connect them. How are we feeling so far? Oh, I need to do the interval, sorry. Beginning, end. This interval begins -1/2. This interval ends +3. Does the -1/2 get a bracket or a parentheses? Do the best you can with spelling. Good. So -1/2 gets a parentheses. Why? How do we know -1/2? Good, good, good. Yeah, it doesn't have that equals 2. You guys are getting it. Perfect. Awesome job. All right. What about the 3? Bracket or parentheses? Good, good. Okay, so far so good? Okay. So now obviously we're going to go a different direction. Now I'm giving you the number line and you have to do the other 2. All right, so I'm going to start with the inequality notation. Can everyone see here how I have those 2 and that line is connecting them? All right, so that means x has to be somewhere in the middle. So here's how I always start it. X, give yourself some space on either side. 2 less than symbols. We'll fix it whether it needs an equal sign here in a second. So this one, you see how the open, I hate using this phrase, but it works. You see how the open mouth is facing the X? All right, so when we cover this in like elementary school, we always say the alligator eats the bigger number. It means X is bigger than something because the alligator is eating the X. Okay. So I'm going to put the smaller number on the other side. That's 1. But it has to be less than 5. Beginning and end. Are either one of those dots closed? So I don't need an equals to. So this is my inequality. And we have interval notation. I can see where I begin at 1. I can see where I end here at 5. Open, non-inclusive, it's exclusive. So I get parentheses. All right. Example B, same exact idea. I can see I have a segment. I am starting at 2, ending at 7, which means X has to be somewhere in the middle. So our inequality notation, start with your X, less than's on either side. So on this side, X has to be greater than, so it's got to be bigger than the 2, but less than the 7. What do I still need to do here? Good, good, good. Add a line under the alligator. I love that. We need an equals to. Okay, these are inclusive. So for our interval notation, clear beginning at 2, clear ending at 7. Excuse me, I closed dots. I had equals to. How do I show both of those things on an interval? What symbol do we use? Good, good, good. All the brackets. Let's flip the page. Making sure we're going to get done in time. I'm pretty sure we will. Kind of. Okay. Got a couple more examples here. All right, so I can see -3, I can see -1 here. So in my inequality notation, x has to be between, always less than symbols, -3, -1. Which one of these gets the equals to? Perfect. Equals to. Now we'll do interval notation. We're beginning at -3. We're ending at -1. What's going to go around the -3? Good. So negative, I see the parentheses around the -3, and then I saw a whole bunch of you already put the whole thing in with the bracket around the -1. So you can mix the symbols. They don't all have to be both parentheses or both brackets. You can mix them. Okay, next one. Okay, this time you don't have a beginning, you don't have a line segment. We have a 5 and an arrow pointing off to the right. How would you compare 6 to 5? Is 6 greater than or less than 5? Good. So that means all these x's on that side of the 5 have to be greater. So our inequality notation, x is greater than 5. Okay, what does it need with it though? Tyler, that infinity is going to go on with our interval notation. So just on inequalities, we need an equals to. Okay, their inequality, yeah. Inequality is separate from interval notation. Okay, so finish inequality. Now we're looking at interval. I have a clear beginning. Actually, I'm going to erase the 6. I have a clear beginning at 5. Okay, my end is a right arrow, which means I need an infinity. Okay, what symbol goes up? If you will, I mean, I know you can't really write, like type in an infinity sign, but do the best you can. Put that interval in the chat and see what you get for your um, punctuation symbols. Creative with the use of the zeros and the O's. Well done. don't know why I didn't even think about using the little O's. That's awesome. So 5 gets a bracket. Good, good, good. And infinities get your parentheses. All right, well, let's do one more. All right, so now I can see 0 here. And this time, my arrow is pointing off to the left. So let's compare. How does -3 compare to 0? Is it greater than or is it less than? Good. Okay, which means x has to be less than 0. Does this one need an equals to? Good. So our inequality notation is done. X is less than 0. Now I need my interval notation. All right, so this time I can see I'm beginning with a left arrow. So if I'm beginning with a left arrow, that means I'm beginning at a negative infinity. Left side is negative infinity. Where am I ending? Okay. Go ahead and put the correct interval in the chat for me. Some of you have already done it. Good. Good, good. Both parentheses. Well done. Okay, now here is where these number lines, this idea of a number line is going to come into play. Okay, domain and range from a graph. Okay. We've been doing domains this whole time because domain is left to right. Okay, it's horizontal. Right? That's what all these number lines have been. They've all been horizontal number lines. Okay, so these have all been domains. So when I look at a domain from a full-on graph, I'm looking at left side to right side. So I'm going to look on the very left side of this graph. Right. Give me this, thank you. Right here. And I'm going to look at the very right side of this graph. Okay, now I'm going to try this out with you. I'm trying out a different way of talking about domain and range from the big graph, from the full-on graph. So I want to see if it makes any sense. When I look at the very left side of this graph, okay, I'm going to consider like a number line. When I look at the very left, I see a closed dot. So I'm going to look down on the x-axis, and that closed dot is at -5. So I'm going to label my closed dot over here as -5. Okay, so I'm beginning, this is our beginning, at -5. Then you want to follow. You can use your pen, you can just kind of use your eyes, but I'm going to show you with my laser. Follow that graph around. If it's continuous, so it's still going, you're just going to keep going. So it's still continuous. And then I get to the right side. And what do you see here that I'm covering up currently? Okay. We have an arrow there, so I need you to be so, so, so careful in this one. This arrow, yes, it's pointing mostly down. but it's also going ever so slightly to the right. So we're ending with a right arrow. All right, now look at all those number lines we've just done. When I ended with a right arrow, I started with that -5. I'm going to go off to the right, ending with a right arrow. You see everyone with me on that. On the very, very left side, I had a closed dot, so I closed my dot. Look at that X value. That's a -5. We look on the very, very left or the very, very right side. So on the right side, I have an arrow as well. So I'm ending with a right arrow. So this is my number line. And so when I think of that number line, I can say, okay, my domain begins at -5. And since it's ending with a right arrow, I'm ending at an infinity. And -5 gets a bracket because it was closed. And all infinity signs get a parentheses. All right. That's horizontal lines. We've been doing domain for this whole time. Range, however, takes your number line and makes it vertical. So we're gonna make a vertical number line. Okay, on a vertical number line, your as numbers get bigger, they go up. As numbers get smaller, they go down. Okay, so range is bottom to top. That's still least to greatest. So I'm gonna start at the bottom. What do we see at the bottom? Yeah, we have that other arrow. All right, so I'm ending, or sorry, I'm beginning with a down arrow. And then I'm going to keep going up. The graph is continuous, so I'm going to keep going up. Nothing is breaking. And I see the very, very top. All right, here, the very, very top. That's still a closed dot, right? So I'm going to end with a closed dot. You guys see how I drew that highlighter right here? That's pointing me to my Y value. What is that Y value? So that's not a -5. I know it's kind of hard to see. There we go. That's a +5. Okay. So if we are beginning with a down arrow, that's the same as beginning with a left arrow. So we're beginning with a negative infinity. And we're ending with a +5. Where is it? Wait. All right, so down arrow. Pretend that looks right. Negative infinity to 5. So negative infinity gets a parentheses. And +5 gets a bracket. Your domain and range don't have to be the same. So I wish there were more examples in your notes of this. If you're in the essentials class, I think there's quite a few of these types as well, and we'll definitely be going over that. But actually, we do have one more example. I lied. Okay, domain. That's our horizontals. So I'm going to look in the very, very left side. Okay, and I see a very, very left side. I'm going to draw a number line here. It's not a great one, but it's a number line. And I see on the very, very right side, I have a closed up. Closed up. I'm going to look up, and I can see that x value is -3. Now I'm going to go to the very, very, very right side, which is here. And I can see that that is an open dot. And I can see that that open dot is on that little bitty 2 there. All right, so my x has to be between -3 and 2. So I'm going to connect these. All right, so I'm asking you to do both interval and inequality here. So interval, I can see beginning, -3. I can see end at 2. -3 with a bracket, 2 with parentheses. Okay, so now we're at an equality. And since they're connecting, that means x has to be between. So x with 2 less than symbols. Left side, -3. Right side, 2. -3 needs something, though. It needs an equals to. Good, good. It needs that little line underneath it, whatever you want to call it. I don't care. Okay. Quickly going in through range. Bottom. So we were looking at the bottom. I'm going to draw a vertical number line here. And at the bottom, I see a closed dot. And I'm going to look over and see what that y value is. And that y value is -5. So I need you to be so careful on range here. This is where range gets people. I want the very, very top of this graph. The very, very top is here. I've got a lot of students that want to stop here, but that's not the top. The greatest possible y is the 4. All right. Now, unless you very clearly see an open dot, you can assume a closed dot. I don't have any skips or breaks in this graph all the way through. So I know that these two have to be connected. So it means my interval, we begin at -5 and we end at 4. Okay, since -5 was closed, bracket, and +4, since I don't see an open, it must be closed. All right, inequality, just like I did with domain, x is between, but this is range, so it's not an x. It's a y. The range is y's. Still gets less thans. So it's got to be greater than the -5, but less than the 4, both with equals to. Okay. So here, these are the ones I was just a hair nervous about because this is something I would cover in an advanced math class. Is given an equation finding a domain, not range, just domain. So these are the three functions that have some kind of restriction. X cannot be certain numbers. The first type we have rationals. Okay, and I know I have a rational when there's an x in the denominator. The reason there are x's that are completely excluded is because you have a fraction. You can't divide by 0. So we're looking for the number that I have to leave out. All right. So we set the denominator, the bottom of the fraction, not equal, because it can't equal 0. And we solve it. So let me give you an example of that. Look over here at B. How do I know this is a rational graph? Variable in the denominator. So I know this is rational. All right, so we set the denominator, just the denominator, the numerator doesn't matter here, just the denominator, not equal to 0. We're still going to solve it like it's an equation, but it's a not equals to. All right. So my first instinct here, and you can do this in a couple of different ways. All right. If I can, I want to keep that x positive. Right now it's negative. So I'm going to add it. But what you do to one side, you do to the other. So negative x plus x cancels out. It's a 0 now. So I have 2 not equal to x, which I can reflect, excuse me, and say x not equal to 2. All right. So we have to write our domain in interval notation. So I want you to draw a number line, just a little one. We're going to put 2 there. Since x can't be 2, we have a symbol that means excluded. It's an open dot. Okay, we haven't seen one of these yet. All right, since that's the only excluded value, that means everything less than negative 2, or excuse me, positive 2, and everything greater than positive 2. I use 2 different colors here for a reason. I have 2 separate intervals. I have pink and I have orange. They are 2 separate things. So if we're concentrating on just one interval, let's say we concentrate on the pink interval. My pink interval, I don't know what you used. All right. The beginning of my pink interval was a left arrow. That means I begin at negative infinity. The end of my pink interval was the 2. All infinity signs get parentheses, and 2 is open. You guys with me on the pink interval? Okay, now we go to the orange. All right, this time the orange begins at 2, but it ends with a right arrow. Well, that's an infinity. All right, well, 2 is still open, parentheses. Infinities get parentheses as well. All right, now, I don't know how they're going to have you do it in Lumen, but the final answer. You want to do it down here in green. The pink interval goes first because it was the left. So negative infinity to 2. Then you're going to draw this little U. That is the math symbol for or. I don't want you to worry too much about it, but for this problem, you need that union. Okay, it's called a union. So we have the pink interval, and now we have the orange interval. That is your final domain. Okay, I'm literally throwing you to the fire on this one. Sorry. Okay. Next one. Even index. These are square roots, radicals. Okay, so I know you guys can't zoom in a whole lot right here, but our typical radical is a square root. All right, but above this little tail right here, you might see other numbers. Like I know you guys might have seen a cube root. That's an odd number. You may have seen a fourth root. That's an even number. So other than a square root, okay, a square root's understood. This is an understood 2. Even index radicals. So 2, 4, 6, 8. Those numbers, so it's called a radicand. Those numbers can't be negative, but they can equal 0. Okay, you cannot take this at this moment. You cannot take the square root of a negative number. Okay, that's a different type of number. So we take the radicand, the stuff under the radical, set it greater than or equal to 0. All right, so that example is D. So everybody find D. All right, I'm going to take the stuff under the radical. Okay, and I know this is an even index because I don't have anything in that tail area. So this is an even index radical. So we take the stuff under the radical, 7 minus x, set it greater than or equal to 0. Okay. I'm going to treat this differently than I did example B. All right, I want to keep the variable right where it's at. I want the variable on the left side. Okay, it's going to make your life a little bit easier here. So keep the variable where it's at. All right, so I'm going to move this positive 7 by subtracting it because I want to keep x where it's at. All right, I've got a negative sign and an x. So negative x greater than or equal to negative 7. I don't want a negative. This is like saying negative 1x. Okay, I don't want a negative 1. I want x. So I'm going to divide both sides by negative 1. Okay. I don't know when last time you guys worked with inequalities was, but if you multiply or divide by a negative, you have to flip your inequality symbol. Only with multiplication and division. All right, I am dividing by a -1. So my what was a greater than or equal to is now less than or equal to. And then -7 divided by -1 is 7. Okay. Sketch a number line. Put your 7 on that number line. That's an equals to. 7's closed. On which side of the 7 are the x's less than? Good, I see an answer there. Which side? Good, good. The great thing about it is it's not as psycho, like all over the place as the rational was. It's literally just the left side. We're not going to go that big. That's a little too big, but that's okay. Really emphasizing my point right here. All right, so in interval notation, okay, beginning with a left arrow, which means I'm beginning with a negative infinity. And I'm ending with a 7. Infinities get parentheses. Closed dots get brackets. Okay. Our next one is called a logarithm. We're not covering that till unit 4, so don't want to cover it right now. But this thing right here, that x, that's called an argument. Okay, so the argument has to be positive. So just like I did with like the even index, I would just set it greater than 0. Okay, we'll do that on a future problem. Here's the great thing. Literally everything else is negative infinity to positive infinity. No restrictions on the domain. Okay, and then our last little bit, it says if you're working with a real world function, consider what makes sense. For example, time moves forward, not backwards. Okay, that's just how time works. That's the major one. Time moves forward. Like physical objects, like my can here. Can I ever have a negative amount of these cans? Yeah. So like physical objects have to stay positive because it doesn't make sense to have a negative number of objects. Okay. All right. So example A here. I don't have a radical. I don't even have a denominator. That has a domain of negative infinity to positive infinity. That means there's nothing that's left out. Okay, by the way, this is called a quadratic. We talked about it last week. Highest exponent is a 2. We already did that super fun example B. Now we go here. And we have this lovely little guy. Okay, ready, take a deep breath. How many variables do you see in the denominator? I have 2, right? I have 1 in these parentheses and 1 in those parentheses, which means we have 2 restrictions on the domain. Right? So we set the first parentheses equal to 0 or not equal to 0. So x can't be 2. We're going to add 2 to both sides. And we set the x plus 5 not equal to 0. So we're going to subtract 5 from both sides. Okay, I'm going to do this above. I have a little bit more space for my number line above. So I'm going to put a number line. Okay, make sure your number's in the correct order. -5 is the smaller number, so it goes here. Right. So Mariah asked, it's not equal to 0 because it can't be 0. That's exactly right. 0 in the denominator is undefined. Okay, if you try to divide by 0 in a calculator, it's going to tell you, no, you can't do it. It's an error. All right, so going back to my number line, the smallest x that it can't be is -5. The bigger x is 2. Okay, I'm excluding them, so open dots. But guys, those are my only excluded values. So unfortunately, what that means is you have 3 intervals. We have less than -5. We have between -5 and 2. And we have greater than 2. And again, I'm purposely using 3 different colors because that means you have 3 separate intervals. Okay, so no, I'm not going to write out the whole process here. Let's say we start off with the green. I'm beginning the green on a left arrow. Let me see that here, left arrow. All right, so if I'm beginning on a left arrow, that means I'm beginning with a negative infinity. Where does my green end? Good. Where does my green end? I'm seeing lots of it. -5. Infinities get parentheses. -5 is open. Now I'm in the pink interval. Where does pink begin? Still a -5, right? Where does pink end? Yeah, pink ends at the 2. Beginning at -5, ending at the 2. Both open, both parentheses. Okay, remember it's beginning to end, left side to right side. Now we're on orange. Where does the orange interval begin? 2 again. And it ends at a right arrow, which means it ends at infinity. Okay, 2 is open. Infinity is always parentheses. The only thing extra that you need is the little unions between them. Okay, I am just about out of time here. Shoot. Essentials. I would rather kind of go into our essentials time and get done with this than stop here. Does that make sense? Because I think we all need to see, yes, I think we all need to see what's coming up next. Okay, so here's what I'm going to make a note. we're not necessarily going to have time to cover all the stuff in our essentials, but there's a lot of practice problems. Let me think about it. We still have to meet for a little bit. That way you can see things, but I'm going to pick out problems for you guys. Okay. Okay. Deep breath, everybody. Okay, this really should be like 3 separate lessons, but here we are all in one. Piecewise functions. All right. In that word piecewise, you should see the word piece. Okay, that means you're encountering bits and pieces of different functions. Okay. I'm not a fan of the way this looks, but I get where it's coming from. Okay. So when you see a piecewise function, you may see 2 or 3 different formulas, different little equations. So they'll tell you one formula and then tell you its domain. So I gave you an example here. I'm going to highlight it. This is my first formula. And it's saying that all my x's have to be less than -2. So the only x's I can put into that orange formula are less than or equal to -2. Then it might give you a second formula and give you a second domain. So my second formula, -2x with its domain. And then a third formula, not always, but sometimes, and its domain. All right. Please believe me when I say you do not have to graph these by hand. All right, that is a hard effing no. Okay. You can graph these in Desmos. Okay. I do have to show you how to write a piecewise function. Okay. So I want you to pay close attention here. All right. It says Shell gas station, which should be capitalized, so that's bothering me, is having a sale on diesel. If you buy 5 gallons or less, you pay $2.89. Where is that gas located? Like, come on. You pay $2.89. Okay, if we buy more than 5, $2.64. Okay, so let's see if I can figure this out. So it says write a piecewise function for n gallons of diesel. I'm going to say C, cost. Okay, so C, depending on the number of gallons. You're looking for little phrases that tell you a rate of change. So I have a little phrase right here. It says 289 per gallon. I don't know how many gallons. That's why it says per gallon. So we say 289 times N, because N represents the number of gallons. But when is that the price? Okay, there's a weird restriction on that. When are you going to pay $2.89? Good. So I'm seeing it all over. 5 or less gallons. That means N, number of gallons, has to be less than or equal, because it says 5 gallons, 5. Okay, and this is a weird one. I'm going to give yourself, you might need to give yourself a little bit more space. So remember when we were talking about how word problems, you have to think in context? This is a physical object, right? This diesel fuel exists. Can you have negative amounts of diesel fuel? Right. So that means it has to be greater than 0. We have to buy something. I can't buy nothing. So it has to be greater than 0 as well. Okay, now I'm not going to say equals to zero because if you're going to get gas, you're putting something in that tank, right? You're not putting nothing. All right. And then I see this one, 264 per gallon. So that's going to be our next little piece. When does that occur? When are you going to pay 264? Okay. So this one's a little, I don't want to say ambiguous, but we have to be careful on this one. Okay. You've already bought 5 gallons. Okay. At 5 gallons, you're still paying 289. If you buy 5.5 gallons, though, we go greater than that five, now you're paying 264. So the five is not included because you included it here. That makes sense? Our next example is similar to this one. Museum charges $7 per person. All right. For a guided tour with a group of 1 to 11 people. Or a fixed $84 fee for 12 or more people. Okay, write a function, so costs depending on people. I just lost my train of thought. All right, so first thing I have is the $7 per person. Okay, they're telling us the number of people is n, so I know this is going to be 7n. When the number of people in the group, we have to have a person, so 1 to 11. Okay, but I think that that inequality symbol with the 11 is missing something. What do you think it's missing? Mhm. Yeah, we need an equals to because it says 1 to 11 people, right? Line under the alligator, 100%. 1 to 11 people. Okay, now the last section of it says $84 fee. Does it tell you 84 per person? Or does it just say 84? Right. So it's not a rate of change here. If I have 12 or more people, I'm paying $84 no matter what. When n is greater than or equal to 12. Question two. Okay. Now, to enter a piecewise function in your graphing calculator, in your Desmos, so use Desmos. All right. It's kind of programming it. So if you're able to write it down, or if you've already got it printed, this is the function that we're trying to graph. How you enter it in Desmos, this is all one single line. You write the condition, so that's the first domain, colon, rule, comma, second condition, colon, rule. All right. So what I want you to do now, okay, is we're going to put this in Desmos. Okay. So everybody pull up a tab. All right, I'm going to change this because I just like the way this one looks better. You don't have to. Okay. The first thing you have to put in there, you have to put f of x. Okay, I'm on my iPad, so it's a little harder, but all Desmos has this ABC. You type in your f, then go back to your 1, 2, 3s, parentheses, x. What that's doing is it's labeling, it's identifying and defining a function, which is incredibly important when we get to this next part. And we want an equals to. Okay, then we're going to go back to ABC. And we want the braces. So if you look on the bottom row, at least on mine, bottom row, I have braces. I go back to ABC or back to 1, 2, 3 because X is right there, but you could have it in ABC as well. So X, we're typing in the first domain. X is less than or equal to 0. Your colon, we're not done with that. Where's my colon? It is right here. All right. So in that bottom row, my colon is grayed out. So I have to hit the up arrow and it gets me my colon. If you're using a keyboard, just type in a colon. All right. And we're typing in x plus 4, comma. Next one says x is greater than 0, colon, 3x minus 2. And then end your brace. Nope, close that. All right. So that little, this for me is amazing because I'm getting ready to show this. This is my next unit in my advanced math class at the high school. So I'm so glad I've learned that you can do it all in one line because I always learned it as individual lines, which makes it incredibly difficult. All right, now I have this graph set up so I can see where the endpoints are. Okay, I can't point to them on here, but you see how you have a point that's directly under the 5? Right, that point, you're going to put it in parentheses, 0, comma, 4. You see how it puts that point there for you, right? You go into the next line, and I'm pointing at my iPad like you can see me. Under the 0, kind of 2 spaces down, that's another ordered pair. So 0, 2, or that's a lie, 0, -2. I'm doing that so you can see the endpoints. All right, but both of those are closed right now. If we look at the first line, equals 2, so it should stay closed. Great. But what about the second one? Should the second one be open or closed? Okay, we're looking here. So should this one, there you go, open or closed? Okay. Now, let me show you how to put an open dot. All right. So we're putting an open dot on the second one. So it's the one when x is great, excuse me. All right. You click and hold. See if I can get it to work here, which now I can't. I can't get it to work on my iPad. I don't love that. There it goes. Yes. Okay. Click and hold, and you have all these options. I want to click the open circle. Yeah, you can change the color if you want to, but that's kind of a find your joy situation. Great. We have it graphed. All right, so I write all those instructions there. Okay. And why this is important is because if I've defined the function and I need to find a function value, then all I have to do in one of the lines is say f of whatever. So if I go back to my Desmos, go into that next line and type in f of 0, not with a y. See in that bottom of that line, that bottom right side of that line, it tells you. I didn't know it did that. So f of 0 is 4. Who knew? Okay. Now we're going to try our own. Okay. So, sorry, just because I don't want to keep flipping back and forth. I'm going to go up. I'm just going to go ahead and clear these. I'm going to type in my f of x. I'm going to need my brace. Okay, remember it's condition first. So the first condition, x is less than or equal to 1. And then it's colon. And it was negative x plus 2, comma. Second condition, x is greater than 1. Colon. Negative 2x minus 1. Okay, this time I can see where that top piece is. Where that end is at 1, 1. So I'm going to put a 1, 1. And that bottom piece where it starts is at 1, negative 3. All right, so my first condition had an equals to. So I'm going to leave the solid red dot. But my second condition didn't have an equals to, so it's open. Okay. So we're supposed to match the graph. Okay, I know it can't be this one over here because it doesn't match the graph at all. All right, so the only difference between these two is the open versus closed. All right, so here's my 1 on both of these. All right, so my choices are x is less than or equal to 1, x is greater than 1. Okay, so I'm looking at the less than or equal to. Less than means left. All right, so the left side, where I have the graph on the left side, here's left, here's left. I want the one to be closed. So that's got to be this one here. Okay. So now we do our function values. F of 1 is 1. Notice it did not tell you 3, -3. That's a good hint there. Tells me +1. F of 0. That's 2. And F of 2. -5. Okay. That was so much. There's nothing else on this. All right. I oh, don't love that for you. Thank you for letting me know. Um, I think my essentials, we probably do still need to meet for a few minutes. I would just want to look at the piecewise functions and we can look at other questions involved. Okay. I'm going to let this load, get that recording in, and get it loaded into your Blackboard. Okay. Probably by the end of the night. You do this week. We're at 8:25 and 8:27. You do have a quiz. Okay, that's like a homework quiz. All right. It's not something you have to go to a testing center for. All right, you take it at home. All right, you have 3 shots. It takes the highest grade. It is timed, so watch your timing. Okay, it's going to cover 1, 2, and 3. This also means that you can have, I see you're good. This also means that you can use your notes and kind of go back and study a little bit. Okay? So your homework for this week is 1, 3, the quiz, and 1, 4. Okay. Everything can be turned in by September 11th for full credit. You do still have to use a late pass. These due dates are there so that you know when you're on track. All right, so if it's past those due dates, you have to use a late pass, but it's not going to count off. Okay? Okay. I am going to go ahead and close this out and kind of get into the essentials. I'm going to get another Diet Coke because I'm dying. And then essentials, I'm going to start pretty much like within the next 3 or 4 minutes. Okay? If you've got questions, please, 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 please email me so I can help out. All right. So have a good evening, essentials. I'll see you in like 3 or 4 minutes. Okay?